Yeah. Uh, Hello everyone. I hope I am now audible and visible to you. Really sorry, there was a technical issue because of which I got a little delayed. और थोड़ी आदत भी है. But anyways, the idea here is today we'll be talking about the LRDI section of CAT 2022. This is slot 3. Now, the idea is not just to solve these questions because again, solve to kar loge. It is more about what happened because this is a paper that I gave live in the actual CAT, and therefore I'd also like to share how I was handling this paper or what went through when I was attempting this paper. That is also the idea of this session. So when I came to the LRDA section, this is the order in which I saw the question. So this was the first question. Now, how do I choose or how do we choose or let go of a set is very important. And I think in the LRDA section, the first point of order should always be get one set down. Once you have 5, 6 questions marked, the level of confidence really goes up. So this was the first question. Now, when I look at this question, there is a number of people who are distributed in ratios. A lot of ratios is given that there is one a definite number here as well, 30 students in ML. So this is the information that I had, right? So on the face of it, I might want to go for this question because at the end of the day, I just have to do a distribution. So this is the information that we had. Then I look at the questions. If you look at the questions, you'll realize all of these questions are definitive questions. None of the question asks you minimum maximum. None of the question asks you what may be or either or that those answers are not given. Therefore, if I actually go about solving this set, chances are I'll get the values for all the numbers that are required. So this could be one set that I could solve, and therefore I mark it saying, okay, this is one target set that I'm looking at, but there is calculation involved which might take time. So I look at the second set again. This was the second set that we had. Now, the moment I look at this set, there are definitive numbers given. There is no ratio as such. There are 4 pie charts, and then you had to solve the question. Therefore, this is a kind of question that I would want to pick up. Of course, DI is something I'm comfortable with, so that does affect my choice. But since there are definitive numbers and the numbers are very, very small 180, 230, 220. So, on the face of it, this looks like a set which I might be able to manage. So I went through with this set in the sense that I read the set. Also, side by side, just look at the questions. If you look at the questions again, you will see all are definitive questions. How many females, how many males, how many individuals, all the options are definitive. So it is a deterministic set, basic DI, and therefore this was a question that I started with. I actually did not read the questions further because I knew I could be done with this set very quickly. And if I am able to get say 5, 6 questions in the first 10 minutes, that goes a long way in boosting the confidence. Okay, so I'll start with this set. It said. A study to determine mortality rate for diseases began in 1980. The study chose 1,000 males and 1,000 females, followed them for 40 years until they died, whichever came first. The so time or death, whatever. 1,000 males were chosen 1980, and they were then divided 250 each of ages 10 to less than 20. So 10 to 20 there were 250 people, 20 to 30 250, 30 to 40 250, and 40 to 50 there were 250. Over the next 40 years, these 40 to 50 age group will turn to 80 to 19. That is what the line chart shows us. Similarly, 1,000 women were chosen in the same bracket of ages and 250 each in each bracket. Then it says the 4 figures depict the age profile among the 2,000 individuals who were still alive in 1990, 2000, 2010, 2020. The blue bars in each figure represent the number of males, and pink bar in each figure represent the number of females. uh, at that point in time, the numbers next to the bars give the exact number given being represented by the bars. So the exact value is also given. I don't have to read the chart per se. For example, it says we know that 230 males among those tracked who were alive in 1990 were in the age group 20 to 30. So this is what he's talking about. So in 1990, also it says a year corresponds to 1st January of that year. So 1st January 1990, 230 males were in the age group 20 to 30 is what it is saying. Therefore, I started with this set, or again a set that can be started with very without too much of a hassle. Really, I'll make a if you are comfortable with it, you can directly deal with these values. If data on the screen is something that is not very you're not very comfortable with, you might want to make a chart in your rough sheets to work upon for the questions, right? So what I'm doing is I look at 1980, 1990, 2000, 2010, and 2020. I look at the age groups. In 1980, we started with 10 to 20, and these age groups will go up to 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90. So these are the age groups that we have overall in the chart. In 1980, these four age groups had 250 people each. To start with, the information told us this. Over the next 4 years, what will happen is these 250 people will go into this age group, and for this age group in 1990 the number is 230. So all I have to do is copy these numbers as it is: 230, 235 in that order, 210, and then 190. For 2000, this age group will go to 30, 40. So 2000 in the year 2000, so this number will become 180, 205, 160, and then 100. In 2010, this number will become, or these people will come in the age group 40 to 50, and the numbers will become 150, 165, 90, and 25. And finally, these people will turn into the last age group, which is 140, 125, 50, and 5. So, how I read this data is in 1980 to 90, there were 250 people in the age group 10 to 20. 20 of them died, and therefore the rest 230 became in the age group 20 to 30 in the year 1990. In the next 10 years, 50 people died and 180 people were remaining in the age group 30 to 40, and so on. That is how the data is panning out. Similarly for women as well. I look at the question, it says in 2000, what was the ratio of number of dead males to dead females among those being tracked? Now, in the year 2000, the total number of alive males was 180 plus 205 plus 160 plus 100. If I add them, I get 2, 3, 4, 5. 500 plus 80, 580 plus 60, 640 and 645. Therefore, the number of dead males will be 1000 minus 645, which is 355. Now, at this point, I could have safely marked 71 as the answer, because 355 is a multiple of 71 only, I think, from the given option. When I'm taking the ratio, this has to be the answer. If you wanted to check, you could have checked for females as well. So in the year 2000, the number of females is this: 210, 175, 50 and 10. So 2, 3, 4, 5, 500, 75 and 10, 85, 135, 155. So 655 becomes the number of females alive. Therefore, the number of dead females will be 345. 355 upon 345 is 71 by 69. The moment I get 355, I know the answer is 71. Question number 7, there were 90 people alive here. And the third group, there were 90, for women, there were 100 people alive here. Therefore, the total number of people who are alive will become 100 plus 90, which is 190. As I said, if you're comfortable looking at the values from the graph, as it is, you can use the graph. If you're not comfortable, in that case, you might want to draw a table and use that table according to your requirement. Question 8 then said, how many individuals who were being tracked who were less than 30 years of age in 1980 survived until 2020? So less than 30 years of age in 1980 would be the first two groups. we have to look at it, the number of people who survived till 2020 in the first two groups. So these are the two survivors: 140 plus 125, which is 265, and 100 plus 105, which is 205. And therefore, the answer simply becomes 470. 9 says how many males who were being tracked and who were between the age of 20 and 30 of age in 1980 died in the period 2000 to 2010. Now look at this question. We are looking at just males for the age group 2030 during 2000 and 2010. So 2030 in 1980. So we are looking at the second group from 2000 to 2010. As you can see, the second group, the number from for the second group went from 205 to 165. So 40 males died during this period. The 10th question, again, this was just one tricky question in the set. It said, how many of the females who were being tracked and who were between 20 and 30 in 1980 died between the age of 50 and 60? So, 1980, 20 and 30 is the second group of people, second group of women, 20. So, we're looking at the second group of females. The number for the second group of females is 225, 175, 145, and 105. We have to see how many of these died between the age group 50 to 60. So when this year started, 2000, 175 people were in the age group 40 to 50. Over the next 10 years, they would be in the age group 50 to 60. And at the start of 2010, we see that the number is reduced to 145. So we started with a number as 175. Towards the end, the number was 145. Therefore, 30 women had died during this period. A very simple question, even if you're solving it in the exam, will not take more than 10, actually not even 10 minutes, but in the first 7-8 minutes you will be able to get the answers down. This happens in the exam, you know you've gotten a good start. Even one more set if you do, you are safe for the section. Then was this question which says there are 4 neighborhoods LTPK during the onset of pandemic, number of diseases on each. So for this kind of a set, clearly it is an arrangement set, missing values are there. The values for 5 days and 4 neighborhoods. Also for each of the neighborhood, the only value that I have to put in is 0, 1, 2, 3. The total value for any neighborhood or any day will not be very high. For example, for every neighborhood, if I am putting 3, the maximum possible number will be 15. Since the information is limited in that sense, I might do this question. But if I look at the 4 sets, 1, 2, 3, 4, I have already completed set 2. Out of 1 and 3, I would prefer doing 1 and then going to 3, because again, this is a missing set value. I might not be able to get the cases. And once I look at the question, I realize there is a possibility that there could be more than one answer possible. It is possible. And therefore, in my pecking order, 1 is before 3. Then I come to the 4th set. It says 4 players are playing a game. There are rounds, rupee 1 or 2 is exchanged. There are some values and there are lots of missing values. Now, if I have to compare 1, 3, and 4, 1 is a definitive set where I will have to make equations and work with ratios. 3 and 4 are sets which are where there is logic involved. I might have to fill in the values. Therefore, in my pecking order, I am going set 1, set 3, and then set 4. So I go back to the set that I am going to attempt, which is set 1. At this point in time, I have 5 answers marked. So I come to set 1. It says, all the first year students of CS department in a university take both courses AI and ML. So there are 2 courses, AI and ML, and CS students have to go for both the courses. For other departments, that is non-CS students, they can take one of the 2 courses. So for the non-CS department students, they will either take AI or ML, but not both. Thank you. So Venn diagrams are not included here. Students who fail in a course get an F grade, others pass in ABC. So if I now look at the information broadly, there are 2 courses, 2 types of students, and 4 grades that they are getting. The following are some additional facts about the number of students who took the 2 courses this year and the grades they obtained. So I just copied the information on the next slide to help me solve. Now, if you are able to categorize this information properly, right? So the probability of you solving the set will increase. If you are writing random numbers here and there, for example, if I write, say, AI CS A, then I write AI non CS B, and all of the information is scattered, I will not be able to solve the question for sure. So what I'm doing is I am making a table which talks of AI, the subject, ML, the subject. For each of these subjects, we will have CS students and non-CS students, right? Also, for these students, we need their grades. So I make four rows for that. The grades could be A, B, C, and F. If you are comfortable, just mark the lines. Oh yeah. All I have to now do is fill in the values, and hopefully I'll get an answer. It says the number of non-CS students who took AI and ML were in the ratio 2:5. So last row I am making as the total number. Non-CS students taking AI and ML were in the ratio 2:5. So if this number is 2x, non-CS, this number will be equal to 5x. Right. Next it says the number of non-CS students who took either AI or ML was equal to the number of CS students. Okay. Now the CS students have to take both courses in any way. So the sum of these two should be equal to the number of CS students. And CS students will take ML as well as CS. So the number of CS students taking both the courses will be 7x and 7x is the sum of the non-CS students. Now, when you are solving such a question from the screen, a good see right now I am just crossing out the information points on the screen. If you're taking this on paper, obviously not write all the information. It might be a good idea to simply write 1, 2, 3, 4, 5, 6, 7, 8 for the number of points. Now, since I've used point 1, I will cancel it. When I use point 2, I will cancel it. You will actually get a feel of what information you've used and what you've not used. So 1 is done for me, 2 is done for me. Says the number of non-CS students who failed in the two courses were the same, and their total is equal to the number of CS students who got a grade C in ML. So if the number of non-CS students who failed in the two courses were same, suppose this was Y, this will also be Y, and therefore number of students, CS students getting uh, grade C in ML will be the sum of this, which will be 2Y, right? So line 3 is also done for me. In both the courses, 50% of the students who passed got a B grade. But while the number of students who got A and C grades were the same in AI, they were in a ratio 3:2 for ML. This is a breakup of ABC. I have not reached till that point. Therefore, I leave information for at this point. No CS student failed in AI. So I'll put a 0 here in front of F for CS in AI. While no non-CS student got an A grade in AI. So for AI non-CS, A becomes 0 as well. 0.5 is done. 0.6, the numbers of CS students who got A, B, C grades are in the ratio 3:5:2. So this ABC is in the ratio 3:5:2. The total is 7x. Here it was 0. Therefore, 7x has to be divided in the ratio 3:5:2. Very clearly, 3 plus 5 plus 2 is 10. Therefore, 10 has to be, or 7x has to be divided in 10 parts. So there is a very good likelihood that x will come out to be a multiple of 10, so that the 7x becomes a multiple of 70 or something. I am not writing this right now because I'll get a decimal. The 3/10 of 7 is 2.1x. I'm not writing that right now. I'll see if I have to eventually. So I'm making a box here. While ML is in the ratio 4:5:2. Okay, we know that the in ML CS students who got grade C was 2y, and since this ratio is 4:5:2, so this will be 4y, this will be 5y, and this will be 2y. Right, 4:5:2 ratio. So this part is also used. 6 is almost done. One part is left. I boxed it out. The ratio of total number of non-CS students failing in one of the two courses to the number of CS students failing in one of the two courses is 3:1. Now the total number of non-CS students failing in one of the two courses is y plus y 2y. This to the number of CS students failing in one of the course, suppose this is say Z, is in the ratio 3:1. So Z will become 2y by 3. Now, where will CS students fail? They have not failed in AI. So obviously these students will fail in ML only, 2y by 3. 7th is also done. Lastly, it says 30 students failed in ML. Now, what is the total number of students who are failing in ML? It is 2y by 3 plus y. 2y by 3 plus y, which means 5y by 3. This is given equal to 30 according to information number 8. So from here I get the value of y as 18. The moment this happens, a lot of numbers will start filling out. So again, I am drawing this table here. On paper, I would not have to draw it again because there will be enough space to write the numbers. But on the screen, I'm struggling a little bit. Hopefully, I'll get better with time. Right? So yeah. Okay. A, B, C, F total. So this is what we had. Okay. Okay. Now I got the value of y as 18. So if I put in these numbers, 4y will be 72, 5y will be 90, 2y will be 36, 2y by 3 will be 12. Should equal to 7x. So if we add these numbers, we'll get 7 and 30 is 100, 9 and 90 and 10 is 100. So 210. Okay, so the total number of CS students in ML is 210, which should be equal to 7x. So x comes out to 30. The moment this comes out to 30, I can write the total number here is 210. The total number here will be 150. The total number here will be 13 into 60. And here it will be 210 again. Right? We had a y here which is 18. We had a y here which is 18. This was a 0. This was a 0. Now that you have 210, we can use this information of 352. Dividing this in the ratio 352, I'll get 210 upon 10 is 21. So 63, 105 and 42. Right. So this is a breakup that I have. Now let us look at the fourth statement because that was giving us a breakup of the distribution of the grades. It says in both the courses, so individually for both of them, 50% of the students who passed got B grade. So let us look at AI first. So how many students have passed in AI? All the 210 from CS and 60 minus 18, that is 42 from non-CS. 252 students have passed. Out of these, half, that is 126, got a grade B. We know that 105 students are already here. So to make grade B 126, I just need 21 students. Also, since the sum of this is 60, 21 and 18 is 39, subtracted from 60, C grade will also be 21. Again, this is a redundant information then. While the number of students who got A and C grade were the same for AI, I've already calculated that, I think. This is for non-CS students. They were in the ratio 3:2 for ML. It should have said non-CS students as well. But anyways, again, working with this number, the number of students who have passed ML is 210 minus 12, which will be 198, plus 150 minus 18, which will be 132. So a total of 320, 330. 330 and therefore half of that 165. 90 of the CS students passed BA. So to make the number of students with passing with grade B 165, I need 75 here. Now when this happens, I can find out the number of people they were in the ratio 3:2 for ML. I can find out the ratio for ML from here. But just look at the questions for one. How many students took AI? 210 and 60. 270 students took AI. I know this. How many CS students failed in ML? CS students failing in ML was 12. How many non-CS students got grade A in ML? So I'll have to break this down now. So what I'm doing is, I look at the number of students who are left to pass. Out of 150, 75 got B. 75 are remaining, minus 18, which will bring down the number to 65 minus 8, which will be 57. 57 cannot be divided in the ratio 3:2. Okay, the total number was there, 63 and 63. Fine. So this number has to be in the ratio 3:2. I made a mistake here. Sorry. So the number of students getting A and C grade has to be in the ratio 3:2. Out of the 330 students who passed, 165 got grade B in ML. So 165 are left. These have to be in the ratio 3 is to 2. 165 by 5 will be 33. This has to be 99 and 66. Now for ML A grade to be 99, 72 is already there. So this will be 27. And for 66, I will need 36 plus 30, 66. Now my table is complete. I misread the information. So how many non-CS students got grade A in ML? Grade A in ML for non-CS students was 27. How many students got grade A in AI? Got A grade in AI. Okay. A grade in AI 63 plus 99, which will in AI. How many students got grade A in AI? Okay, that is only 63 for that because CS was non-CS was 0. How many non-CS students got grade B in ML? Non-CS students grade B in ML is 75, and that is done. So now if I look at the time that is required, again, even if this takes another 10 minutes, so what I'm saying is, so set 2 ended up taking suppose 8 odd minutes, set 1 ended up taking say 15 minutes. In about 23 minutes, I would have gotten 10 questions done. Do you know what is the what was the percentile if anyone got 10 questions in this exam? The percentile for this section would cross 99%. And this is a real data. You can obviously check it, go back and check the. All I'm saying is, if you get one set down, you will have enough time to figure out one more set for sure. You do that, your 99% is percentile is safe as far as the exam is concerned, right? And that is all you need to do for LRDI. It is not very difficult. It is just about understanding what to do and breaking it down like that. Then came site 3. Site 3 said there are only 4 neighborhoods LTPK during the onset of pandemic in a city. The number of new cases of a disease in each of these neighborhoods recorded over a period of 5 days. On each day, the number of new cases recorded in any of the neighborhoods was either 0, 1, 2, or 3. Following facts are known. I'm taking on the next slide. The cities were LTPK. So, will I write day or huh? So let me write it as LTPK, the cities, the neighborhood, sorry, and then day 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, right? In each of these blanks, I will be putting 0, 1, 2, or 3. There is a very good chance there will be a total involved as well. So I'm making two, a column and a row on the extreme ends so that I can fill in the total as well. Right now it says there was at least one case in every neighborhood on day 1. So here there will be at least one entry, at least one in all the columns. There will be no 0. On each of the 5 days, there were more cases in K than in P. So this value will always be greater than this value for each of the numbers. The number of new cases in the city in a day kept. So the values here for each day will be in an increasing order. The number of new cases on day 3 was exactly one more than day 2. So if the number of cases here was x, it will be x plus 1 for day 3. X plus 1 and x. This is also known. The maximum number of cases in a day in pessimisto was 2. So the maximum possible cases here for P was 2. All other values will be 0 or 1. This happened only once. Great. So for pessimisto, 2 will be there once. Rest of them will be ones and zeros only. K is the only place to have 3 new cases on day 2. So for day 2, only K will have a value of 3. The rest of them cannot have a value of 3. The total number of cases LTPK in the OK. The total number of cases was also given as 12, 12, 5 and 14. Now if I have to look at 14 by entering 0, 1, 2, 3 over 5 days, what is the only possible combination? 14 can only happen if I have 3 4s and a 2. That is the only combination possible. What about 5? I know that one of them was a 2. The rest are ones and zeros. So it has to be 2, 1, 1, 1 and 0. That is the only combination possible. For 12, multiple things can happen. I could have 3 4s and a 0. I could have 3 4s, no, 4 3s and a 0. I could have 3 3s, 9 and 2 and 1. and so on. So there are multiple cases there. So what I'll now do is I will try to fill the numbers here and see what happens. See, the total number of cases was 12 plus 12 plus 5 plus 14, which comes out to 24 and 19, 43. So the total number of cases over the 5 days should also be 43. What is the maximum number of cases that can happen on day 5? That will happen when all of these values are maximum. So this is 3, 3, 3, 9 and 2. The maximum possible cases here is 11. When L, T and K have a value of 3 and P has a value of 2, which are the maximum values for those neighborhoods. If I take a value of less than this, for example, if I take the value here to be 10, the maximum values for all other days will be 1 less than the previous number. So 10, 9, 8, 7, 6. You add them, you get a total of 13, 15, 28, 38. This cannot add up to 43. 10, 9, 8, 7. This cannot add up to 43. I am making a mistake, I think. 13 and 17. So sorry, this is 40. This cannot add up to 43. So 10 is not a possibility for day 5. So day 5 number has to be 11. And that can only happen when I have 3, 3, 3, 2 and 3 happening for each neighborhood. So day 5 is sorted for me. Now we have to look at day 2 and day 3. See, 43 divided by 5 in equal distribution gives me a number of 8. If I look at two cases, I put a 7 here and an 8 here. Right? And I'll try to see if this works out. Now, if this is a 7, this is an 8, the total number of cases that have been counted are 7 plus 8 plus 11, which is 26. Therefore, another 17 cases are required. For that 17, either I'll have to write a 10 here and 7 here. So, increasing order is not being followed. Or I'll write a 6 here and 11 here. Again, an increasing order is not followed. So, this value cannot be 7 and 8. Anything lower than 7, 8 will also not work out. Therefore, the next possibility is that the numbers are 8 and 9. In that case, the number of cases done is 8 and 9, 17 plus 11, 28. So 15 cases are left, which can happen with, see, on the fourth day, the number has to be more than 9 and less than 11. So the only possibility is 10. And for the total cases to be 43, it will have to be filled by 5 here. So I write a 5 here, 8 here, 9 here. I'm crossing out this, 10 here and 11 here. Now I have to fill in this 5. We know that on the first there was at least one case in each of the neighborhoods. Also, the minimum value that K can take is 2. So if I put 2 here, I will have to put a 1, 1, 1 to get a 5. Right? So that will be the breakup for day 1. Now what I can do is, since this is 3, no other value can be 3 and I need a sum of 8. The other 3 values have to add up to 5. If I put a 2 here, I can have multiple cases. That will not work out. Okay. Also, what we know is 9, 10. Now, if I look at this 10, since 2 has already been filled for K on day 1, the rest of the values have to be 3 and 3. Since this is 10 and for P 2 has been used, so I can only use 1 or a 0. So the maximum possible value is 1. So 3 plus 1 is 4. Therefore, a total of 6 is required. That has to happen with 3 and 3. That is the only possibility. So now day 1 is done, day 4 is done, day 5 is done. If I look at L and T, 3 and 3, 6, 7. The 7 values are done. Therefore, 5 is left for both L and T. So one of the values in L will be 2, the other will be 3. Similarly for T. Also, I need 1 for P as well. Now, if we look at it, there was one in each of the 5 days, there was more cases in. So 1 is taken care of, 2 by default will happen. The number of new cases in city in a day kept increasing in the 5-day period. This has been taken care of. The maximum number of cases in pessimist was 2. This happened only once in 5. I have to put a 1 or a 0, so that will be taken care of. This is to have 3 new cases in day 2. This has okay. Now on day 2 only K had 3 cases. So the possibility for LN2 has to be 2 and 2. 3 plus 2, 5 plus 2, 7. Therefore, P has to be 1. Now that 1 has been used for P, the only possibility left for P is 0, and therefore L and T have to be 3 and 3. I get a definitive chart, and therefore the question is solved. It says what best can be concluded about the number of total cases in the city on day 2. On day 2 there were 8 cases, therefore option 4. What best can be concluded about the number of new cases in L on day 3? Number of new cases on L on day 3 was 3, exactly 3. On which day did P not have any new case? P not having any new case was again day 3, only day 3. Which of the following two statements are necessarily false? There are 2 new cases in T on day 3. 2 new cases on T on day 3. No, it is not. There were no new cases in P on day 2. We know that this was on day 3. Therefore, both of them are false. Therefore, both statement A and B are false. How many days did L and T have the same number of cases? 1, 1, 2, 2, 3, 3. On all the 5 days, they had the same number of cases. This question is also done. Now, if I look at the attempt number, there is a possibility that if you're not able to spot this, cracking the set becomes a little difficult. But the moment this happens, you'll be able to crack the set. And therefore, I said if I'm comparing set 3 and set 4, set 3 was a lot more doable than set 4, right? Even if you're not cracking this entire set, there is a very good chance that half of the set is done, and therefore, 1 or 2 questions you're able to do from this set, right? In any case, 10 questions, as I said, was more than enough to get a 99 percentile for 2022 in slot 2 for LRDI. Coming to the final set, I think this was a decently difficult question. Getting stuck with this question would have created an issue. It says P, Q, R, and S participated in a tournament comprising of 8 rounds. In each round, they formed 2 pairs, with each of them being exactly in 1 pair. Right? The only restriction on the pairing was that pairs would change in successive rounds. So if there is a pair in one round, for example, P and Q, then P cannot pair with Q in the next round. That is what is explained as well. He would be free to pair with Q in the third round again. In each round, each pair decided whether to play the game in that round or not. If they decided not to play, then no money was exchanged between them. If they decided to play, they bet either 1 or 2. So if they choose bet rupees 2, then the player winning got rupees 2, losing 1 gave the rupees 2 to him. Okay. At the beginning of the tournament, the players had 10 rupees each. The following table shows partial. Okay. Now, when you have a table and people are changing money between them, what will happen is the total amount of money will remain the same. Nothing is going out of the system. It is just changing hands, and nothing is also coming in from outside. So the total amount of money will remain the same. As the following table shows partial information about the amounts that players had at the end of each round. It shows every time a player had rupees 10 at the end of a round, as well as every time a player had either the minimum or the maximum that he would have across the 8 rounds. For example, if you look at Suresh had 10 in round 1, 3 and 8, so that is shown. He did not have rupees 10 in any other round. The maximum amount Suresh had was 13 in round 5, and the minimum amount he had was rupees 8 at the end of round 2. In all the other rounds, he had none of 8, 10 or 13. He had other numbers in between 8 to 13. So the table shows every time someone gets a 10 as the amount or their minimum or maximum. Those values are given. We have to find out what happened in all of the other rounds. We are starting from everyone having 10 rupees each. This is the starting point. For Pulak, the range will be from 10 to 13 because 10 is the lowest number given in his table. For Kasim, it will be 8 to 12. For Ritesh, it will be 4 to 10. Clearly, he's not winning too much. And for Suresh, it will be 8 to 13. This is the range of numbers that we can use for filling the table. Since they started with 40 rupees and round 1 it says 10, 10 and 8. So this is 28. Clearly at round 1, Pulak has to have 40 minus 28, that is 12 rupees. For round 2 as well, it is 13, 10 and 8. So this is 31 rupees. So at the end of round 2, Ritesh has to have 9 rupees. That is also certain because the sum of numbers has to be 40 rupees. So For round 1 and 2, I will also be able to find out the pairing that happened. Round 5, 10, 10 and 13 is there. Therefore, this number has to be 7 so that the sum comes out to 14. Also, it was given, I think, that round 4, these two people had the same amount of money. Let me check. Had the same amount of money in round 4, yes. Right. If I have to fill further, I would probably start with maybe these rounds, right? Because yeah, or let us fill other numbers first and then come to this round. Anyway, the sum of these two numbers is 16, 12 and 4. Therefore, the sum of the numbers in round 7 for the other two has to be 40 minus 16, which is 24. Now, 24 can happen when the numbers are 12 and 12, or they are 13 and 11. That cannot happen, right? If the value at round 8 for Suresh is 10, so 10 can be coming from 11 or 12 because the maximum difference can be of rupees 2, or it could be coming from 8 or 9. If I put 8 or 9 here, the corresponding number for 24 here will have to be 16 or 15, which is not possible because Pulak does not go beyond 13. Also, if Pulak was on 13, that would have been mentioned. It is not mentioned. Therefore, from here I can say, just a minute, the only possibility for the value for Pulak in round 7 is 12, and therefore the possibility for Suresh is also 12. So this is also one value that I am able to fill. The numbers here will be 12 and 12. So clearly, Suresh is losing 2 rupees. So someone has to win 2 rupees as well. Now, if Kasim won 2 rupees, his value will become 14, which is not possible. Therefore, Ritesh will be winning 2 rupees and therefore becoming 6 rupees. Pulak is winning 1 rupee, so someone has to lose 1 rupee. That will be Kasim, and therefore his value will be 11 at the end of the 8th round. So 1, 2, 3, 4, 5. 5 columns are done. We have to look at the other columns now. I start with column number 4. Okay. Now it says that Pulak and Kasim had the same amount of money at the end of this round. Now the same values that they can have, because for Pulak the range is from 10 to 13. For Kasim it is 8 to 12. The possibility of same numbers could be 10, 11 or 12. If 10 was the same number, it would have been mentioned. If 12 was the same number, it would have been mentioned for Kasim because it is his highest. So the only possibility of the same number is 11 and 11, which gives me a sum of 22. Therefore, the sum of these two numbers has to be equal to 20 to 18, right? Now, from round 4 to round 5, Pulak and Kasim are decreasing by 1 and 1. Therefore, the other two have to increase by 1 and 1. So, their values will be 12 and 6 for sure. Another table is done. Another row is done. Now I have to fill 2 rows. What I'll also do is I'll just make the pairing so that no pairing is repeated to be sure. Round 1, Pulak won 2 rupees, Kasim lost 2 rupees. So Pulak and Kasim played a game of 2 for round 1. For round 2, this increased by 1, this decreased by 1. Therefore, P and R had a game of 1, which P won, ONE1 and WN1. For Kasim and Suresh, Kasim won rupees 2, Suresh lost rupees 2. So there is a game of 2, which Kasim won. This is the pairing. So in the next round, P and have 2 rupees. So someone has to lose 2 rupees as well, right? Also, if I look at Ritesh has to go from 9 to 6. If Ritesh ends up winning, he will be on 10 or 11. He cannot go down to 6. So Ritesh will be losing as well. Again, because Pulak is at his highest point, he has to lose for sure. Since 2 people are losing, therefore Kasim will have to win for sure. That goes without saying, right? Also from this point you see, from round 3 to round 4, Suresh is again winning. Ritesh will have to lose, and therefore I'll be left with P and Q. Now, if since there is one win and one loss, 10 can go to 11 or 12, 13 can go down to 12 or 11. From there, the one case could be both of them are 11, 11 and 11. So that will be 22, 32 and 8. That will work. And then both of them will remain the same. So the game will be between P and Q. Again, from 4 to 5, both of them are losing 1. So obviously they will not be playing the game together. That is a possibility. If I have one win or a one loss, let's try to fill this first. Since this person is winning 2, someone has to lose 2. If we assume that this person loses 2, then the game will be between R and Q. P and R cannot have a game. So P has lost. In the previous round, P played R. So now P has to play S. So P and S play. This is a game of 2 which S wins, because consecutive rounds they cannot be playing the same person. Therefore, S's value becomes 11 here. Now I have why is this 18 written here? Now I have these two left. So 11 plus 10 is 21. The sum of these two numbers has to be 19. 19 is possible if this becomes 11 and this becomes 8. Therefore, I have a game between Q and R, which Q wins, and the value of the game is 1. For round 4, then uh, both of them are winning one round. So R could be playing Q or R could be playing P, but in the previous round R played Q. Therefore, R will play P. R will win for a value of 1. S and Q will play in this round. S will win for a value of 1. We reach round 5. Now from here, 7 has to go to 4 eventually. So there has to be a loss and a loss. 10 has to go to 12. There could be a possibility where 10, if suppose 10 loses and goes to 9, it cannot go to 12. So this has to be a win and a win. 10 has to go to 12. If 10 goes to 9, it cannot go back to 12. Therefore, this also has to be a win and a win. Or it becomes stationary, then also it will work out. Hmm. A win and a win is not necessary here. 13 has to go to 12. Of course, this has to be a loss. Only then will 13, because 13 is the highest value for Suresh, it has to decrease in the next round. So these two R and S have to be losses for sure. Therefore, P and Q will be wins for sure. Right? Now, if this happens, also in the previous round, R and P have played. R will not play P. R has to lose. So the next game will be between R and Q, which R will lose, Q will win. And here the game will be between S and P. Oh, between S and P, which S will lose and P will win. Now the possibility is how much do they lose or how much do they win. So if I put the number here as 2 and 2. So suppose both of them will 12 and 12. They will reach 12, 2 and 2. So here the numbers will be 5 and 11. Perfect. So now what I can do is in this round, round 6 to 7, I can have a match between. This was for round 1 match. This is round 2, round 3, round 4, round 5. For the round 6 match, I could have uh, I think यहाँ मैंने I've made a mistake here. 1 and 1, 1 and 2, 1 and 2. So here I could have a match between R and P and Q, which ends in a tie, and for R and S, which उधर नहीं. Sorry. I got a little confused, but okay. Now okay. Now here what will happen is uh, R and Q have a match for 2 points, which Q match for 2 points, which P wins. Then to go from 6 to 7, P and Q will have a match, which is a zero sum game. And here R and S will have a game which S will win for 1 point. Finally, to go from 7 to 8, this is an increase, this is a decrease, increase of 2, decrease of 2. So P and Q will play a game of 1 point, which P will win. R and S will play a game of 2 points, which S will lose, R will win. Something like this will happen. Yes. So I think this kind of a statement should work out. Basis this, we go on to the questions. As I said, this is not a question that you would want to try in the exam. Even if you are, it is a good idea to stop somewhere in the middle and look at the questions. For example, what best can be said about the amount of money with Ritesh at the end of round 8? This is a value that we had calculated earlier, and therefore I might actually mark this, right? Second is, what best can be said about the amount of money that Pulak had at the end of round 6? I have marked this as well. But what I'm saying is, in the initial frame, I had question 16 done. When I had marked the first 4 or 5 rounds, I was able to solve this. How much money did Ritesh had at the end of round 4? This is something that I had to find eventually. How many games were played? Again, this will be possible only at the end of the whole calculation. Which of the following pairing is made in round 5? Round 5 again. So even if I'm able to solve half the sum, there is a chance I might be able to mark 1 or 2 questions. So when you're looking at this question in the exam, it may not be a very bad idea to just mark the questions that you're able to solve and move from there. All right. So yeah, that is what I had to share with you in this session. Again, we will keep doing these sessions on alternate days, at least so 2 or 3 days a week. The idea will be, this is what happened with me in CAT 2022. When as far as I am concerned, I did set 2, I went to set 1, which I was able to solve partly, and then I could not solve anything in the actual exam, to be really frank. पेपर बहुत खराब हुआ था मेरा. But anyways, this is what happened with me. Going forward, we will look at uh, questions topic wise as well. So in the coming lecture series, we will look at different topics in LR. We will keep going back to previous year questions to see how you could have attempted those questions better. And maybe sometime next week we'll also have a small session on how to prepare going forward for LRDA, because for maths the plan seems to be pretty simple. For English also, there is some idea of what you're doing. LRDA is very, very perplexing. So sometime next week we'll have a session on how to prepare in the next 4 or 5 months for the LRDI section. And apart from that, we'll be covering different topics on LRDI, looking at different sets, new sets that you can solve. Ideally, I'll be sharing that set with you guys maybe prior to the session. So it'll be a good idea that you join or subscribe to our channel, join our Telegram group, so that sorry, WhatsApp group, so that you have an access to the set that is going to be solved. And the idea will be to run this series till cat happens, right? So even if nothing happens, you will have had enough practice for you to manage the cat LRDI section for this year's cat, right? So that is mostly what we had to share. I hope you were able to find some value in today's session. Looking forward to having a lot of sessions with you. If there is any feedback, please let us know. It is the idea of this is not to do sessions. The idea is to see some improvement in your performance. Otherwise, all of this is kind of a waste. So yeah, that's about it. Thank you very much for your time. Hope to see you soon, very soon. Probably day after tomorrow if all goes well. Until then, take care. Do get in touch if there is anything we can help you with. The rest all is great. So have a great night, day, whatever time you're seeing this. And if there is any issue, please let us know.